So this is the assignment for looking at hypothesis testing. So I have sent you an email with the data for this particular project. And I just need to get my cursor working here. Okay, everything's good there. Okay, so this is the project associated with looking at hypothesis testing. So I have sent you a file with some data. I forget exactly how many data points are, but we'll find that in a minute. And the question is the data that I give you statistically significant than this number? So what we're going to do is we're going to say the population mean. This is the population of the original data is 72.5. And the null hypothesis will be that this mean for the population is equal to, we'll call it mu nu. So that's the data that I'm going to send to you. The alternate hypothesis is that the new value is greater than the old value. So this is going to be a one-tail test. And we're going to use all three methods to prove this, and we should get the same conclusion, whichever way we do it. Okay, so the first thing we need to do is to find the average and standard deviation of the data. So when you go to your Gmail account, you'll find data for hypothesis testing. And it may not look exactly like this because I just sent this to myself, but you'll have a file. It's an Excel file, and you're going to download it, and you're going to save the file because we're going to open it using Google Sheets. So we save the file, and it will be saved to the downloads directory on your computer. Okay, so now we need to go into Google Sheets. So we click on the waffle, go to Sheets, and we're not going to, well, we're going to start a new spreadsheet. I guess actually, I think we can see if I try to remember some place that you can open a spreadsheet. Let me see if I can find where that is. Let's just try that, open file picker. Okay. Yeah, so we're going to do that. We're going to go to upload, select file from your computer. You go to the downloads directory and your latest data file. If you do this by date, I'm not sure why it's not changing here. Anyway, data for hypothesis testing. So that's the one that I just downloaded. So you double click on that. It uploads the data. It's going to ask us something. Actually, it opens it automatically. It doesn't even ask anything. So there's our data. This will be the same data that you have. And if we scroll down, we have 27 data points. So I want to find the mean and the standard deviation of that information. So I'm going to type in this cell, and I'm going to type in equals mean, left parenthesis, highlight the cells that have the data, put the right parenthesis, push enter. So the data, the mean of the data is, oh, I keep doing that. It's supposed to be average. Average. Enter. Enter. Let's try again. Okay, so the average is 74.06. And then we'll do the standard deviation. So equals STDEV, left parenthesis, highlight the cells, 27 cells, right parenthesis, enter, scroll back up, 2.75. So let's write those on our sheet. 74.07. So the sample's mean is 74.07, and the sample standard deviation is 0.75. Okay, so the first thing is the confidence interval method. He's just going to be doing the same order that we've done in class. So if we draw our picture, just draw our generic normal distribution. So this is our data. So our data has a mean of 74.07. That's our sample mean. And the question is, where does 72.5 sit? So let's we'll use 90% confidence interval. So what we're trying to do is figure out what limits here, A and B, are such that we have a 90% confidence that the population mean for the sample condition is within this range. And if this number is greater than that number, then if this number is less than that number, this number is greater than that number, we'll reject the null hypothesis. If it's over here, then we'll fail to reject the null hypothesis. So if you remember what we did, we found the standard deviation of the sample mean by taking the sample standard deviation divided by the square root of n. So our sample standard deviation is 2.75. Our number of data points is 27. So get my calculator. You get your calculator. Let's see here again. 2.75 divided by the square root of 27. So that is 0.529. Okay. The next thing we do is we find what the critical t-score is. And we get that from the table. And this is going to be a function of 26 degrees of freedom, and we're going to do 90% confidence. So we need to go to the internet and put in our now familiar search term, critical t-value table. Okay, so there's the magic chart. So we go to the bottom, 90% confidence level, 26 degrees of freedom, critical t-value is 1.706. 1.706. So that means that our margin of error is our critical t-score times the standard deviation of the sample mean. So that's 1.706 times 0.529. 1.706 times 0.529. It's equal to 0.903. And then our confidence interval, so this is the confidence of what the population mean is for the same, under the same conditions that we collected the samples. So we take the sample mean and we subtract the margin of error. We take sample mean and add the margin of error. So 74.07 minus 0.903, 71.07. 73, sorry, 73, 73.2, say, and the higher number is 74.07 plus 0.903, 74.97. So we'll round it off, 75.0. Okay, so this number here is 73.2, this one is 75, and because 72.5 is less than 73.2, what we can say, since 72.5 is outside the 90% confidence interval, we reject the null hypothesis. So we are basically accepting that there is a significance difference. Okay, so that's the first thing we do. Now, we can actually use most of this stuff for the second part of the problem. This is the critical t-score. Critical. So the only difference is, we have all the same data, but we're going to calculate the t-score associated with 72.5. So t is going to be 72.5 minus, actually I think it's the other way around. You take the we take the mean 74, sample mean, subtract 72.5 and divide by this 0.529, the standard deviation of the sample means. So 0.529, 74.07 minus 72.5 divided by 0.529. So we get t equals 2.97. So therefore, t is greater than t critical. So the same thing. So therefore, since, we put a little word, since the t is greater than t critical, we reject the null hypothesis. And then the third method, what we do is, with the p-value method, we calculate the t-score, which we actually just did here, t equals 2.97, and we use that plus 26 degrees of freedom plus one tail. Again, we use one tail when the null, or the alternative hypothesis says that one is greater than the other instead of not equal to the other. So we can, let's see if there's a, hopefully there's a Google Sheets formula that works for this. So we'll look under formulas. So if we, I think, what was the one we had? T something. I wonder what T inverse does. So what did we say? We say we put in the t value, 2.97, comma, number of degrees of freedom, 26, and it looked like there was a function that was for two tails. So I'm going to just try that and see what happens. Oh, didn't like that. Okay. Parameter 1 is 2.97. It should be less than or equal to 1. Okay, apparently that's not the right function. So I'm going to pause. I know what it is in Excel, but I think it was like tdisp. So, but I'm going to find out what it is in Google Sheets. Okay, so I couldn't find one in Google Sheets, so I'm just going to show the answer in Excel. So the function, if I make this thing a little bit bigger so you can see it. So the function is equals tdist, left parenthesis, you put in the t-score, 2.97, number of degrees of freedom, 26, number of tails, 1. You get a p equal to 0.003. Okay, so 0.003. And I might show you how to use it during the table, just to give you an idea. 0.316, I'll just say 0.32. Okay, so that's the p value, and since 0.0032 is less than the level of significance, which is 0.05, that's what we used here to get this t critical. I kind of skipped over that part, but if you go back here and the significance level for one tail test is 0.05, which corresponds to 90% confidence level for the confidence test. So if you take 26 degrees of freedom and this same column, 1.706 is the answer. That's how we got the wherever it was here. .706. So so that's where this number comes from, and you see it's less. It's quite significantly less. So it's a pretty sure thing. How do you use the tables to do this? So here's the table. So you can see the probability is if we look for a t-score of 2.97, because that's what I got here, 2.97. And looking over at 26 degrees of freedom, you'll see 2.056, 2.162, 2.479. So it's between these two values. It's between 0.01 and 0.005, I think. No, actually, it's not, because what does I have? I got 2.97. Okay. 2.97. It's between these two. It's between 0.005 and 0.0025. So let's write those numbers down, and I'll show you how you would interpolate. So 0.005 and 0.0025. So the corresponding values were 2.779 and 3.067. 3.067. And our real value is here, and that's actually the real value is right here. No, 2.97. And we're trying to figure out what it is in here. So you can kind of work it as a ratio. 2.79 minus 2.97, so those subtracted, divided by the total difference, 2.779 minus 3.067 is equal to, so that corresponds to that, 0.005 minus x divided by this number, 0.005 minus that number, 0.0025. And so let's do these calculations. So the left-hand side, 2.779 minus 2.97 divided by 2.779 minus 3.067. So here I get 0.663, 0.005 minus x, and if you subtract that, you get 0.005 minus 0.0025, which is 0.0025. And if you cross multiply here, you get 0.0025 times 0.663, which is 0.00166 is equal to 0.005 minus x. So x is equal to 0.005 minus 0.00166. And you get 0.00334. Okay, so that's using, interpolating from the tables. This is using Excel. So they're pretty close, 0.0033, 0.0032. So what do I want you to send me? I want you to send me the spreadsheet. So do like you've done before. Just have, you don't need to have anything there. Just have the data and the mean and the standard deviation. And then email that to me as an Excel file. And then hand in paper with these calculations on it. Okay, so that is it.